Hello, Calculus 1 students. My name is Professor Ken. I am here in Venezuela at Angel Falls. Did you know that Angel Falls is the largest waterfall in the world? All right, enough of that. So this video, the purpose of this video is to go over with you problem set 36, which is the problem set that is due today. So problem set 36 is due today, which by today I mean Friday, April 28th. So I'm going to go over it. I'm going to do every problem for you out loud. And hopefully it will help you because you have to know this stuff for the final. All right, so let me share my screen. And I'm going to turn off the video so my good looks don't get in your way. All right, now I'm going to go to open the app, which is called Whiteboard. There it is, Microsoft Whiteboard. And how do I know what the assignment is? Okay, so the assignment is 4.5, 11 to 23, 35, and 52. So it's 4.5, 11 to 23, and I kind of forgot them already, 35 and 52. Okay, so I'm going to 4.5 and I'm looking at number 11. I'm going to read it to you. Number 11 says, of all the rectangles with a perimeter of 10, which one has the maximum area? All right, so let's make a rectangle. And its perimeter is 10. So 10 equals 2x plus 2y. Now it says which one has the maximum area. So we know that area is x times y. So we need to have, we're looking at area, we're going to maximize area. So we need to only have one variable. So look up here, I'm going to take away 2x from both sides. So 10 minus 2x equals 2y. Now I'm going to divide everybody by 2. And if I do that, I get 5 minus x equals y. So I'm going to take that and I'm going to substitute it right here. So I have area equals x times 5 minus x. Distribute the x. So we have area equals 5x minus x squared. All right, so how do we maximize area? Well, we take the derivative, set it equal to 0, and solve it. Oops. So a prime is equal to 5 minus 2x. Set that equal to 0 and solve it. And we get x equals 2.5. Now, if the perimeter is 10, we have 10 equals 2 times 2.5 plus 2y. All right. 10 is equal to 2 times 2.5 is 5 plus 2y. Take away 5, we got 5 equals 2y. So y is 2.5. So the dimensions of the rectangle are y equals 2.5 and x equals 2.5. So it's actually a square. Okay, great. That was number 11. Let us move on to number 13. Okay, 13. Of all the rectangles with an area of 100, which one has the minimum perimeter? All right, so here's a rectangle, x and y. Its area is 100, and the formula for area is x times y. So let's get y by itself. So we'll divide both sides by x. And we have 100 over x equals y. Now we want to minimize perimeter. So perimeter is going to equal 2x plus 2y. And y, of course, is 100 over x. So perimeter equals 2x plus 2 times 100 over x. Now, this is all a matter of perception. I'm going to say that the perimeter is equal to 2x plus 200 x to the minus 1. All right, now we're ready to take the derivative, and then we'll set the derivative equal to 0. So, okay, so p prime equals 2 minus 200 x to the minus 2. Set that equal to 0. And we have 2 minus 200 over x squared equals 0. Let's add 200 over x squared to both sides. So 2 equals 200 over x squared. Multiply both sides by x squared. We have 2x squared equals 200. Divide both sides by 2. X squared equals 100. So x equals 10. Now, going back to the very top here, if x equals 10, 100 divided by 10 is equal to 10, so y is also equal to 10. This too is a square. Right? That was 13. Let's try 15. Find positive numbers x and y satisfying the equation xy equals 12. Such that 2x plus y is as small as possible. So let's call that the sum of 2x plus y. All right, let's start on the left side. We'll divide both sides by x. So we have y equals 12 over x. We'll substitute for y into the second equation. So s equals 2x plus 12 over x, which we're going to call 12 x to the negative 1. Now we could take the derivative, and we get 2 plus negative 12 x to the minus 2. So we're going to set that equal to 0. We get 2 minus 12 over x squared equals 0. Let's add 12 over x squared to both sides. So we get 2 equals 12 over x squared. Multiply both sides by x squared. 2x squared equals 12. Divide both sides by 2. X squared equals 6. And take the square root of both sides. So we get x equals the square root of 6. Yuck. All right, now how are we going to find out what y is? Y is 12 over x. So y is going to equal 12 over x, so 12 over the square root of x. And there we have it. That was 15. We're in the 17 already. Can you even believe that? Wow. All right. So now we're on number 17. Let's start to get real now. A rectangle is constructed on its base on the diameter of a semicircle with radius 5. All right. So I like to go like this. So we have a semicircle of radius 5. And we have a rectangle here. All right. Now the equation for the semicircle is x squared plus y squared equals 25. So if this is x, then this y value is going to equal, well, x would equal the square root of 25 minus y squared. So this is, let's call it 25 minus y squared to the 1/2. So now what's the area of the rectangle? I'm going to put over here. I got this whole big whiteboard. Why not? Area equals 2x. So the base of the rectangle is x plus x, 2x. And the width is 25 minus y squared to the 1/2. Oh, 25 minus x squared. Why I put a y there? Okay. So it's 2x times 25 minus x squared to the 1/2. All right. This is one of those times. No, so we want to take the derivative and set it equal to 0. So watch what happens. So a prime equals 1 d2. Oh my goodness, somebody's calling me. So d2 would be 1/2 times 25 minus x squared to the negative 1/2 times negative 2x plus plus 2 25 minus x squared to the 1/2 d1, which is just 2. And then we would set that equal to 0. Well, guess what, folks? I think I am going to, this is UGLY, you ain't got no L by you ugly. So I'm just going to go to Desmos and let Desmos do the ugly work for me. Let's learn together. So I'm going to let f of x equal 2x times 25 minus x squared to the 1/2. Or actually 2x times the square root of 25 minus x squared to the 1/2. Let me just fix this. So y is equal to the square root of 25 minus x squared. I should clarify that. So let's take this function right here and call f of x and put it into Desmos. So f of x equals 2x times 25 minus x squared raised to the 1/2. All right. Now let's take the derivative of that and find out where that derivative is equal to 0. Shut that off. Okay. Right here, 3.536. So x equals 3.536. And we'll take that, we'll plug it into this y value to find out what the y value is. So y equals the square root of 25 minus x squared. But of course, x is 3.536. Squared. So it's 3.535. Interesting. So y equals 3.535. And I wish I knew what irrational number that was. I'm sure it's an irrational number, but I don't care that much. So there we have it. And we can see 3.535 makes sense because from here to here is 5. So from here to here is 3.535. So what's the, make sure we're answering the question. What are the dimensions of the rectangle? So here are the dimensions. Well, actually, we're not giving the dimensions of a rectangle are 2x times y. So the dimensions, we would have to double that. So that's whatever 3.53. So 3.535 times 2, 7.07. So it's 7.07 by 3.536. And there we have it. So those are the dimensions of the rectangle. Okay, let's go on to 19. That was a real one, for sure. 19. All right. Surface area of the box. Of all the boxes with a square base and a volume equal to 8, which one has the minimum surface area? Okay, so let's make a box. And it's got a square base, so it's x times x. And this is times y. Now it says the area of the volume of the box is 8. So 8 equals x squared y. And that means y equals 8 over x squared. So the surface area, now we have 6 sides. We have the top, we have the bottom, and we have the 4 sides. The top is, the area of the top is x squared. The area of the bottom is also x squared. And the area of each side is going to be x times y, and there's 4 of them, so it's plus 4xy. So the surface area is equal to 2x squared plus 4xy. So the surface area equals 2x squared plus 4xy, but y is 8 over x squared. We see down here. Plus 4x times 8 over x squared. Okay, I want you to look right here for a minute. 4 times 8 is 32. The x is going to cancel with one of the x's down there, so this will be 32 over x, or 32x to the minus 1. So surface area equals 2x squared plus 32 x to the minus 1. All right, now we can take the derivative and set it equal to 0. The derivative is 4x minus 32 x to the negative 2. Set it equal to 0. Okay, so the first thing I'm going to do is divide both sides by 4. Okay, so we have 4, I'm factor out of 4, times x minus 8 over x squared equals 0. So we can divide both sides by 4, and the 4 cancels out. So we have x minus 8 over x squared equals 0. Multiply both, add 8 over x squared to both sides. X equals, I don't need this equal on the front, was 8 over x squared. Let me scroll down. Multiply both sides by x squared. So we'll have x cubed equals 8. So x equals 2. We have to figure out what y is. Okay, so if x equals 2, where's our y? Oh, look over here. Y would be equal to 8 divided by 2 squared is 4. 8 divided by 4 is 2. So y is also 2. Equals 2. And there's our dimensions. So it'd be 2 by 2 by 2. Let's see what the question asks. Of all the which one has the minimum surface area? Okay, so it's the one that's 2 by 2 by 2. And that was 19. What do we have here? We have to go to 23. Piece of cake. 21. Shipping crates, a square-based box. So let's draw that right away. What? So this is x times y. A square-based box shipping crate is designed to have a volume of 16. So the volume is 16, that would be x squared y. So we know right away y equals 16 over x squared. All right, the material used to make the box costs twice as much per square foot as the material in the sides. All right, so the material used to make the base costs twice as much as the material to make the sides. And the material used to make the top costs half as much as the material to make. Oh, I made a mistake on the answer key. All right, so the cost. Now, the sides are going to be there's 4 sides, and they're each going to cost xy plus. The material used to make the base costs twice as much per square foot. So I'll have 2 times x squared for the bottom, and the top is half as much per square foot. So that would be plus 0.5 times x squared for the top. So we have, here's for each side, here's for the bottom, here's for the top. So the cost equals 4xy plus 2.5 x squared. Now we know y is 16 over x squared, so the cost is 4x times 16, some parentheses, over x squared plus 2.5 x squared. Simplify, cost equals, okay, the x, this x is going to cancel with one of those, and then we have 4 times 16. Well, 4 times 16 is 8 times 2. 4 times 8 is 32, times 2 is 64. So it's 64 x to the minus 1 plus 2.5 x squared. Now we could take the derivative and set it equal to 0. The derivative would be negative 64 x to the negative 2 plus 5x. Set that equal to 0. Let's clean this up. So it's, well, let's add 64x to the minus 2 to both sides. We have 5x equals 64 over x squared. Let's multiply both sides by x squared. Ooh, how'd that box come about? All right, so we have 5x to the third equals 64. Divide both sides by 5. We have x cubed equals 64 over 5. And take the cube root of both sides. We have x equals the cube root of 64 over 5. Let's get a decimal for that. Cube root. What the hell is it? Is it a function? No. Or ABC maybe? No. Okay, so I'm going to have to do this and make b equal 1/3. So it's 64 over 5. Raised to the power of, well, I guess I could have used caret, 1/3. All right, 2.34. So x equals 2.34. And then y is going to be 16 over x squared. So let's do 16 over 2.34 squared. 2.92. Those are some funny numbers. So y equals 2.92 and x equals 2.34. Now let's look at the question again. That was number 21. What are the dimensions of the crate that minimizes the cost? So here they are. So it's the base is 2.34 times 2.34, and the y is, and the height is 2.92. All right. Let's take a look at 23. That's a fun one. All right. What point on the parabola equals 1 minus x squared is closest to the point 1, 1? So the parabola 1 minus x squared is closest to the point 1, 1. There's 1, 1. Now, we learned this one in class. So we got to use the distance formula for 2 points. The first point is going to be 1, 1. And the second point is going to be y new x, comma, 1 minus x squared. And remember, the distance formula equals the square root of y2 minus y1 squared plus x2 minus x1 squared. And this is going to be UGLY. You ain't got no value, really. So D is equal to the square root of, now y2 is going to be 1 minus x squared. Y1 is going to be 1 minus 1. Oh, the 1's cancel. That's all going to be squared. Maybe it's not too bad. Plus, that's x1. Plus, x2 is going to be x minus 1 squared. All right. Let's clean this up a little bit. D equals the square root of, the 1's cancel, so we'll have negative x squared squared would be x to the 4th plus x minus 1 squared. And I don't want to take that derivative, so I'm going to do my Desmos. So it's going to be the square root of x to the 4th plus x minus 1 squared. Wait, I need it inside. Plus x minus 1 quantity squared. Yeesh, look at that. That's some graph, isn't it? Wow. All right, so let's call that f of x. And then let's graph f prime of x and see where it equals 0. Egads. Oh, that's interesting. So it's 0 right there, 0.59. So we scroll up. D prime equals 0 when x equals, did I say 0.59? My memory is not that good. 0.59. And now we got to find the y value when x equals 0.59. So it's 1 minus. Okay, so watch this. We turn this one on now. We turn this one off, and we say f of 0.59 is 0.538. So let's make sure that that point's on the graph. 0.59 comma 0.538. It sure is. And let's see if it looks like it's close to the 0.11. It actually looks like the 0.11 is on the damn graph. Oh, that's the derivative. Crap. All right, so the function is, let's call it g of x now. I made a boo-boo. Equals 1 minus x squared. All right, let's turn off this. And the 0.59, 0.538 is pretty close to being on the graph. We got some round off error. Here's the 0.11. So we see that they look like they're the closest points. So our answer makes sense. 0.59, comma, 0.538. So it's the 0.59, comma, that's a 0.538. All right, good times. All right, now we have number, I think it's 32, just to double check. 35 and 52. Okay. 35. Oh, the soda can. So find the radius and the height of a cylindrical soda can with a volume of 354. So here's our soda can. There's the radius. There's the height. So the volume equals, I love this one, 354. And the formula for volume is pi r squared h. So 354 equals pi r squared h. Divide both sides by pi r squared, and we get 354 over pi r squared equals h. Now it says to minimize the surface area, which makes sense because if we're making a can, we want to minimize the cost to make the can. So we have to have a volume of 354, but we want the cans to have the dimension that's going to use the least amount of materials. So everybody knows the formula for the surface area of a can is equal to 2 pi r squared plus 2 pi r h. And h is equal to 354 over pi r squared. So surface area is 2 pi r squared plus 2 pi r 354 over pi r squared. So this r is going to cancel with one of those. The pi's are going to cancel. So surface area equals 2 pi r squared plus 350 is 7 times 2 is 700 for 708 r to the negative 1. All right. Take the derivative. Actually, let's let the Desmos do it. So we'll call it S for surface area. S equals 2 pi r squared plus 708 r to the minus 1. 708 r to the minus 1. Good. Zoom out. Ah. So we'll go from 0 to 4 on the x-axis, and we'll go -1 to 4. And then -1 to 300. So -1 to 4, and then -1 to 300. Let's say 1200. Okay, better. All right. Now we want to find out. Oh, it does turn. We better expand our x. Let's go to 20. Okay, that's better. Because we know we have a minimum there. So let's find out the graph of surface area. All right, let's say S of R. And now let's do S prime of R. Not working. Okay, let's do S of X and change our R values to X. All right, and now let's do S prime of X. Still no graph. Let's try it again. S. No. What was that? X to the -1. Okay, let's do big S prime of X. Okay, it's there. So we'll turn this one off. And now we see that the derivative equals 0 at 3.834. So surface area prime equals 0 when X equals 3.834, which is really the radius. So R equals 3.834. And what is going to be the value of H? Look over here, 354 over pi r squared. So H will equal 354 over pi times 3.834 squared. So 3.3. Oh, wait, I forgot already. 354 over pi times 3.834 squared. $7.67. So the question asks again, number 35, find the radius and height which minimizes the surface area. So here's the height and there's the radius. Now, question B says, in real life, the can is made to have a radius of 3.1 and a height of 12. Why might that be? Well, here's what I say. If we look at the can again, now, if it costs the same to make the top and the bottom and the sides, then the best surface area would be a radius of 3.834 and height of 7.67. But they say in the real world, the radius is 3.1 and the height is 12. And here's what I say to that. I would imagine it costs more to make the top and the bottom because the top and the bottom have that lip going around, you know, it sticks up a little bit. So it probably costs a little bit more to make the top and the bottom. So you want to make those a little smaller and the height a little bit bigger because the height's a little cheaper. That's how I would surmise that. All right, we are on the last problem, which is number 52. There's 52 cards in a deck. In case you were wondering, 52. All right, a load must be suspended 6 meters below a high ceiling using cables that are 2 meters apart. How far below the ceiling should the cables be joined to minimize the total length of the cable used? All right, so what we have is, here's the ceiling. We have two cables forming a Y, and there's a distance of 2 meters between them. That's not going to change. This distance is X. And here's our little weight. And the whole distance is 6. So we want to minimize, actually, let's do a little erase. Just to the end of the cable is 6. So this value right here is really going to be 6 minus X. And we're probably going to have to do a little Pythagorean theorem here. Because we have X here. We have 1 here. So this would be the square root of X squared plus 1. Let me make that bigger over here so you can see it. Okay. So this is 6 minus X. This is X. This is 1 and 1. And here we have a right triangle. So this is going to be the square root of X squared plus 1. So what's the whole cable? Pretty easy. So we have square root of X squared plus 1 here, the square root of X squared plus 1 here, and 6 minus X here. So let's see. A load must be suspended 6 meters. Okay. So the length of the cable is going to be 2 times the square root of X squared plus 1 plus 6 minus X. Because the cable is this length, which is square root of X squared plus 1, plus this length, which is the square root of X squared plus 1, plus this length, which is 6 minus X. And what we want to do is find the dimensions. How far below, okay, to minimize the length of the cable used. So once again, I'm going to let Desmos take care of this function because it's UGLY. You ain't got no L by, you're ugly. And I'm going to call L f of X. New graph. Okay, so f of X equals 2 times the square root of, I forgot, X squared plus 1. Is it plus 1? Yes, X squared plus 1. Okay, and then plus 6 minus X. Okay. Where is the function? Oh, there it is. So now we're going to take the derivative of that and set it equal to 0. There's the derivative. Where does it equal 0? At 0.577. So X equals 0.577. And the question asks, how far below the ceiling should the cables be joined to minimize the total length? Okay, so in other words, where should they be joined? Right here at 0.577 meters below the ceiling. Great problem. Great answer. Okay, so we have now, let me stop the share. Let me turn on my screen. Hi. Okay, so we have now done the entire problem set. The next video will be teaching new material. Bye.